Hello world. I'm Imagination. In this video, I'm going to talk about the odd similarities between the human brain and the entire universe scientists found. An astrophysicist and a neurosurgeon walked into a room. It may sound like the beginning of a bad joke, but what a pair of Italian researchers came up with is a true galaxy brain take. The structures of the observable universe, they say, is astonishingly similar to the neuronal networks of the human brain. University of Bologna astrophysicist Franco Vazza and University of Verona neurosurgeon Alberto Faletti detailed the surprising similarities between the cosmic network of galaxies and the complex web of neurons in the human brain exhibit in a new paper published in the journal Frontiers in Physics. Despite being roughly 27 orders of magnitude apart in scale, the human brain and the composition of the cosmic web show similar levels of complexity and self-organization, according to the researchers. The brain contains an estimated 69 billion neurons, while the observable universe is composed of at least 100 billion galaxies, strung together loosely like a web. Both actual galaxies and neurons only account for about 30% of the total masses of the universe and brain, respectively. And both galaxies and neurons arrange themselves like beads on long strings or filaments. In the case of galaxies, the remaining 70% of the mass is dark energy. The equivalent in the human brain, the duo said. Water. We calculated the spectral density of both systems, Vazza said in a statement about the work. This is a technique often employed in cosmology for studying the spatial distribution of galaxies. Our analysis showed that the distribution of the fluctuation within the cerebellum neuronal network on a scale from 1 micrometer to 0.1 millimeters follows the same progression of the distribution of matter in the cosmic web. He added, but, of course, on a larger scale, that goes from 5 million to 500 million light years. The clustering and number of connections emanating from each node also were oddly similar. Once again, structural parameters have identified unexpected agreement levels, Faletti said in the statement. Probably, the connectivity within the two networks evolves following similar physical principles, despite the striking and obvious difference between the physical powers regulating galaxies and neurons. The team is hoping that their preliminary study could lead to new analysis techniques in both cosmology and neurosurgery, allowing scientists to better understand how these structures have evolved. That's all for today. Thanks for watching.